Now refer to question number 23. Question number 23 relates to a problem of the estimation of nitrogen by means of Dumas method. The question says 0.3 gram of an organic compound gave 50 ml of nitrogen at 300 Kelvin and 715 millimeters of mercury pressure. The aqueous tension at 300 Kelvin is 15 millimeters. Aqueous tension, that is aqueous tension of water, is 15 millimeters of mercury. Now the question asks is percentage of nitrogen in the compound is. This is the data that is given. Now first of all, in this Dumas method, the principle applied is it is the equivalent amount of nitrogen is liberated and the volume of nitrogen liberated from a particular weight of the compound is found out. From the volume, the weight of nitrogen is calculated, and from the weight, the percentage is calculated. These are the, in short, the principles that are involved in this. Let us work out step by step. 50 ml of nitrogen is released from how much weight of the compound? 0.3 gram of the compound. What is the volume of nitrogen liberated? It is 50 ml. But what are the conditions under which the nitrogen is liberated? It is 715 millimeters of mercury pressure. But actually the aqueous tension, that is water tension, also takes away about 15 millimeters. Therefore, the actual volume of nitrogen that is collected is equal to 715 minus 15, which is equal to 700 millimeters of mercury is the pressure of nitrogen that is collected, where the volume of nitrogen is 50 ml. Therefore, P1, that is the volume of nitrogen collected, is equal to 50. The volume of nitrogen collected V1 is equal to 50, and P1, the pressure of nitrogen, that is subtracting the aqueous tension, that is 715 minus 15 is equal to 700. So P1 into V1 by T1 at 300 Kelvin, P1 V1 by T1 is equal to P2 V2 by T2. Now P2 is under the normal, these are all the STP, standard conditions of temperature and pressure. What is standard conditions of temperature and pressure? 760 millimeters of mercury. So that is given there. We do not know the volume of nitrogen at this condition. Therefore, simply write it as V2. And what is the normal, what is the temperature that is given? It is absolute temperature, it is 273. So P2 is 760, V2 to be found out, and T2 is already known 273. So the only unknown factor is V2, which is this. This V2 will give the volume of nitrogen that is liberated from 0.3 gram of the substance. What will be the volume of nitrogen liberated? This is the volume of nitrogen liberated at STP or standard condition. Actual volume liberated is given there, is 50. But that is not the actual volume. We want to reduce it under standard conditions of temperature and pressure. So that volume, when you simplify this, this will work out to 41.9 ml. Now this 41.9 ml of 22,400 ml of nitrogen will weigh 28 grams, and 41.9 ml of nitrogen at NTP will weigh 0.052 grams. So this will be the weight. Now this is not the volume, this will be the gram of nitrogen. This will be the volume. 41.9 is the volume. Since relating 41.9 ml of nitrogen is equivalent to 0.052 gram of nitrogen. Now, if this nitrogen is present in how much of the quantity of the material? 0.3 gram of the material. That is given in the data. So 0.3 gram of the material contains 0.052 gram of nitrogen. Therefore, 100 gram of the material will contain what? Will contain how much? Will contain 17.46% of nitrogen. So the percentage of nitrogen in the given organic compound is 17.46%, which corresponds to choice 4.